Okay, so I'm back. Before we begin today, well, a couple of things, I guess. So I have a few sort of questions to ask you. So one of them is, so I've taught this course before a few times to different groups, sometimes mainly computer science, sometimes not computer science. But one of the things that I always had to do in previous years is devote a couple of weeks at the end of the course to teaching the students another programming language, introducing them to another programming language, usually Java, because they had subsequent courses coming up that would be in Java. Now, in this class, that doesn't make any sense. Just the ratio of people in here who are studying computer science and the people who are not studying computer science. The ones not studying computer science may never need to know Java in their lives, so it doesn't make sense to spend 2 weeks giving you a brief introduction to a language that you'll never use again. So what I would like you to think about, and you can answer me now, or you can answer me in some subsequent class, is what you would like to learn in those last 2 weeks. So is there something special, some special topic that you think would be useful for you going on? If so, let me know and I can try and do something about it. Otherwise, I think what we'll end up doing is sort of revisiting topics from earlier in the course, but hopefully now that you guys have some deeper understanding, some of the more mechanical problems that come up shouldn't be there anymore. We can visit them a little bit deeper. So does anybody have any suggestions right now for more that they would like to see? Yeah?
I have a question. I'm not in the computer science program, but I was told from others in my program that in computer 1006, I think it is, that we would be using Java.
Yeah. You will be, and then you'll sort of have to pick it up on your own. Because there are still a fair number of people here who won't be going on to that particular course, and Java's kind of a specialized language, or at least it's a language that's not typically used by non-computer scientists so much. So I don't want to take up everybody's time teaching sort of Java syntax and the differences between Python and Java. So you don't have to have suggestions right now, but if you do, that's good. The other thing I'd like to sort of ask about is pygame. I guess in a couple of things I can ask is, how's it going? Some people seem to send me emails saying that they're really struggling and they really need more help or more time. Which is fine. But on the other hand, I don't want to spend 5 weeks doing something that one part of the class is really struggling with and maybe will never get sorted out, thereby punishing them. And if the rest of the class is not struggling with it, sort of at least has mastered it enough to the level of this course, then again, there's not much point in me continuing to teach it. So I'll spend, since you're running up sort of against your big project in pygame, I'll spend this week looking at pygame. We'll maybe make a game, or maybe I'll just answer questions, and you can ask me how to do certain things, and we can try and figure that out together. But then probably, after the end of this week, we should be done with pygame. Yeah.
Just so we're clear, assignment is worth the same as all it is?
Every assignment is worth exactly the same. So even though assignment 8 feels like it's a whole huge pile of work and super open-ended, just like assignment 3 was sort of super open-ended and you could do whatever you wanted. It's up to you if you want to put in a ton of effort, but it's not worth more than any other assignment. Okay. Yeah?
Is pygame going to be part of the final?
The final exam is again a multiple choice format, and pygame. So I'm not a big fan of getting people to sort of memorize, huge interfaces and all of the things, for instance, that pygame has to offer. All that information is available online. When you want to know how to rotate an image in pygame, I usually don't remember from one invocation of this course to another. I have to Google it. So I don't expect you guys to have like some enormous repository of knowledge about pygame that you can recite in the final exam. And that's mostly true about most of the things in this course. What I want is a more of an understanding of the way things work. So all that to say, other than trivial questions, which I don't like, it would be tough for me to really test you on pygame during the exam. I can certainly write questions like, does pygame.transform.rotate, what are the 3 arguments of that function? But what's the point? So if I can think of sort of logic questions that have to do with pygame but don't require you to remember a bunch of stuff, then maybe. But really it's going to be sort of logic/programming questions. Nothing pygame specific. Yes?
Are you going to give us the previous midterm?
I'm not going to give you a previous final exam, but I will give you a big list of sort of topics that you can think of, what kind of question can he ask about this topic? And they'll be quite specific, so you can sort of make up your own final exam, or what you imagine could be on a final exam, and then test yourselves and each other. There's no reason not to share these things. Yeah.
Also, is it possible to post the solutions
For
for the first midterm?
the first midterm? Yeah, I guess I can do that. Okay. Send me an email to remind me, please.
Will that be posted this year?
Yes. Yeah, I always have to answer those questions by thinking about how long is it until I teach this course again, and if I post if I post the midterm and the solutions, then that means I can't use anything from it again, and so I'm not teaching this course in the near future, so it's the next instructor's problem. Fine. Yeah.
Will you post the solutions for assignment 6 and 7 before it's over?
Yes. In fact, if you send me an email right now, you have a laptop there, I can go back to my office and post the solutions for assignment 6. I'll have to see if I can find my solution for assignment 7, but yeah. Yep.
What are some of the topics that you think complement what you taught?
Well, sort of in the strong computer science version of this course, I would be so you had a sort of a brief lesson on recursion from my replacement last week. So I would be looking a little more deeply at recursion, and we would also look at performance of algorithms. So very basic analysis of algorithms that we can do in this course, but it's maybe not the most important thing for some of you. I think it's probably important. It's useful for everyone, but if there's some other topic that people would like to see, then I'm open to suggestions. Yep.
Are we going to have some extra assignments?
Well, so we've got 8 coming up at the end of this week. And then we have, I believe it's 3 more weeks of classes. So that would be 9, 10, 11 if we have one every week. That's That's one fully bonus assignment, and I'm considering actually making 2 of the assignments be bonus. So then you get the best 9 out of 11. Yeah.
Will you show another sample of exam papers before the final exam?
Similar to what?
Similar to final exam paper?
Yeah, I won't show you an old final exam, but I'll give you a detailed list of topics to study for. And what I recommend is that you guys sort of be honest with yourselves about reading that list of topics. Are there things in here that I don't understand? And then focus really hard on asking what kinds of questions. What is it about these things that scares me? What question could he ask that I wouldn't be able to answer? And then share that with other people. So on the forums, you can share. You guys can make up between the hundreds of you that are in this course. You can make up like 100 sample final exams, more than you have time to do. So that's your best way to proceed, I think. Okay. So any questions? No. Is there something, let's say, specific pygame type questions that you have that I can try and answer? So how do I do this in pygame, or how do I do that in pygame? Yep. Mm-hmm. Okay. So questions about vectors. So what would you like to... Let's drop into today's folder. So what would you like to know? So for us, a vector, it's nothing special in Python. It's just a pair of numbers. A vector you can think of sort of a couple of ways. The usual way we think of it is it's a pair of numbers that represents, let's say, the change in x coordinates and the change in y coordinates. Another way to think of it, though, is it's really a direction and a magnitude, so a direction and a length. So when we talk about normalizing, that we're typically talking about is going from this first representation, which is an x coordinate and a y coordinate, and thinking in the second representation, which is a direction and a length, and trying to change that length to 1. So sort of getting rid of that length aspect of it and change it to 1. So how do you do that? Well, I guess, I don't know. I guess I can do it with Python code. So Python -i. So if you give me a vector v and I want to tell you its length, then that's the x-coordinate squared plus the y-coordinate squared, and you take the square root of all that. Right? That's the length of a vector is, or if you like, it's the distance between 2 points. You look at the difference in their x-coordinates squared and their difference in their y-coordinates squared. In the case of a vector, it's the distance between the point 0, 0 and the actual values of the vector, the x and y coordinates. And for us, we usually treat, rather than introducing some new structure, we just say that a vector is represented as this pair of 2 points. So that's a function that defines the vector length. We can test it. Vector length of the vector 1, 1. Don't forget to import math. 1.4142 so something. That's a sort of rough estimate of the square root of 2, like we expected. Okay. So you wanted to ask about normalizing. So that would be something like, you give me a vector v, and I want to return its normalized version. Then what I do is I return v at 0 divided by the length, and v at 1 divided by the length. See if I matched my things correctly. So now if I do something like a vector normalize 1, 1, then I get something that looks about right, and I recognize that pretty much as 1 over square root 2, 1 over square root 2. And if you think about that, figure out the length of that thing, well, we can test it. We can ask for its length. Pretty close to 1, so just like you'd expect it to be. Yeah?
I was also having difficulty in like assignment 7 with the mouse clicking, that I couldn't get the function out of mouse clicking then with
Okay, so is it the detection of the mouse clicking? Like, okay, so let's in fact, let's save this thing. So here's our basic skeleton, and you want to know about mouse clicking. So whenever something happens, the user presses a key, or user clicks the mouse, or even the user moves the mouse, an event is generated and put in the event queue. And so what we want to look for then are what are the events that get generated by a mouse being clicked. So we'll use our friend Google, and we'll say something like pygame mouse click event. Okay, so you get a bunch of functions listed here that talk about questions. These are functions that tell you information about the state of the mouse right now. So for instance, pygame.mouse.getPressed will tell me which buttons of the mouse are currently pressed. And pygame.mouse.getPosition will tell me the position. And we'll get a bunch of these kinds of functions. Now this is not actually what we want, because, and we'll see maybe if we get to our example today, that there's sort of two ways to do things, but the game, the question, assignment 7 and a lot of things, in particular mouse click events, should be done makes sense to do them a particular way. What I want to know is exactly when the user clicked the mouse. These kinds of functions will let me know is the user holding the mouse button down right now, but if I want to do something special when they click the mouse, then I want one of these events. So let's go, so let's forget about pygame mouse click events. Let's just look at pygame event types. So event poll, event pump. So here we go. on this page we find a nice list of events, and there's a few of them that have to do with the mouse. Mouse motion will tell us when it moves. Mouse button up will tell us when the user lets go of the button, and mouse button down will tell us when it gets pushed down. So that's that's the one I'm interested in, mouse button down. So if someone gives me an event, pygame dot mouse button down, all uppercase. Let's see what information we can get out of this event just by printing it. And that's called mouseclick.py. Okay, so nothing is getting printed, and now I click, and it tells me. Mouse button was clicked, and there's an event, and the event actually has a couple of attributes. The position, that's where in the window that I click the mouse. You can see that it changes when I move the mouse around. And the button number, this is a left click. In this case, it's the button number 1. And if I right click instead, well, yeah, I'll see button number 1 here regardless. Button number 3 if I right click. Okay. So that there you are getting the event. That's here inside this event loop, this thing that just waits for events. And now you do whatever you need to do to process that event. I think in the assignment you're supposed to play a sound or something. Question about that? Yep. Oh, because there's nothing special to do with vectors. That's just Python. So you're asking, for instance, here, why did I use double parentheses? Well, because the definition of, let's say, vector length, for example, says that this is a function that takes one argument v, which is supposed to be the vector. And so if I do something like, say, vector length 1, 1, well, what's happening there is that's the syntax you use to call a function, so the parentheses after this thing, and then there's a list of arguments that are separated by commas. And so this is me calling a function and providing 2 different arguments. And you get the expected behavior, which is a type error that says vector length is a function that takes 1 argument, called v, but you gave me 2 of them. So maybe it's better to read it like this. There's vector length, and I'm giving it 1 argument. The argument just happens to be a pair, a tuple of length 2. So maybe even better to make that really clear. I mean, this is like me doing this. A little bit more readable. Yep.
This is a question that relates to that, but I have a lot of trouble understanding when I'm making multiple classes, how to pass variable names of information in between the quick classes to try to do multiple functions. I was wondering if you could talk about that a little bit.
Okay. So when you make multiple classes, how to pass information between them. So this is, this is a big question. This is a software engineering question, basically. But sort of the way to think about it is, first try and break things up logically. So in all of these games, there is already this one sort of encompassing class, which is my game. And it's going to be the class that, it handles all the pygame events, it handles, updating things. So it's going to be somehow the coordinator. And in that way, it sort of makes sense that all the information about the game is somehow contained in this class. So, for example, we saw that in the missile command game, there was a whole bunch of missiles, and our class kept them as a list. And then when it was time to update, well, it would go through that list and update each one. And I guess the point is, it also handled all the logic for interactions between these various things was also in that class, right? So when a missile would blow up, it was inside the game class that it would see which missiles were exploding, and then it would go through the list of other missiles and see if they were close enough to any of the exploding ones to see if they blew up. So the missiles themselves didn't know anything about each other. So the coordination was done in a top way like that. So that's sort of the first thing is you should figure out, well, who needs to know about what? Do missiles need to know about each other? Or do instances of this class need to know about other instances of this class, or do they need to know about instances of some other class? And usually the answer is no. Usually it's that there's some upper level logic that coordinates the interactions between those things. And they don't need to know about each other. And if you find that this class needs to know about this class and the other class needs to know about, they need to know about each other, then that's usually a software engineering problem. It's usually a design problem. Think about, little classes deal with them themselves. And in games, it's sort of like there's a logic class, the whole thing, and then there's usually little game objects. And you might think, okay, well, let's say I'm making a game where people, police are chasing a robber. The robber is the player, and the police are other game elements. You might think, okay, well, then they need to know about the robber. Well, no, actually, what the game can do is tell them, just when it updates them, say the robber is here now. You decide what you want to do based on with that information, but they don't need to know everything about the robber, just where its current location is and when that changes. And already that means if it's changing all the time, well, then there's something globally that's handling all of that and updating them. So, without a specific sort of problem, I can't say too much. I can't say too much more than that, other than they shouldn't really have to talk across each, sideways in this direction. It's usually something above deals with all of these things and knows about them. Okay. Now there is a notion of inheritance, which we haven't really done, which is, special types of classes. Maybe we'll end up doing something with that here, where you have classes that specialize other ones, where you might have something like game object is a big class, and game objects know about their position and they can draw themselves. But you have different kinds of game objects. We even in missile command, we had one sort of missile class, and it was handling both the missiles that we shoot and the missiles that come from above. But you can imagine that there's one global missile class and then two kinds of missiles, the ones that come from above and the ones that we fire, and they draw themselves differently and so on. And we'll see that you can represent that in a certain way and save rewriting some code, but I don't want to sort of overwhelm you guys with that just yet. Yep.
For our purposes, for like this assignment number 8, can we put everything into the one game class? Like, would I run into problems not defining extra classes?
You might. The only sort of problems you might run into are are problems of confusing yourself. I mean, when something is really nicely a logical little piece that is completely independent of everything else, it kind of makes sense to just separate it out. Otherwise, you get this, spaghetti sort of code that all of the stuff that you're doing, usually the sort of functions you would include in that class, they just don't, there's no such class, so that the code in those functions ends up in your game code, which is fine, but it may end up in multiple places in your game code, right? Yeah, so just like for instance, in our, again in the missile command game, missiles could update themselves, which meant they moved a certain way. And then when we wanted to update everything, well, we just had to iterate through the list of missiles calling update on each one. And, if we had different kinds of missiles incoming and outgoing, that would mean we'd iterate through two lists and maybe be duplicating the code inside two different loops. But usually, with a little experience, you can start to see, if I'm copying and pasting blocks of code from one place to another, maybe there should be there's a logical place for that piece of code that those two locations can share. Sometimes it's just factored off into a different function, sometimes into a class. Depends what you want to do. Yep.
Can you show how a start screen would work for the game initialized?
Sure. So let's go with this one. You might say something like, we want a game with a start screen. So it doesn't just come up and you immediately start playing, but it waits for something from the user. So already that means that somehow the game has more than one state. Or when the window opens up, it opens up into some different state than you playing the game. It opens up into the start screen state. So the first thing I would do in that case is say, well, in our init function for our game, we should create some attribute called state, and we'll call that start. And that means associated with our class, we can have a couple of things. A couple of states might be start and playing. And maybe start is really just the integer 0, and playing is the integer 1. But when the game fires up, we're in the start state. Okay, so now the game comes up in the start state, and so that means in a few different places now we need to deal with the fact that there's sort of two things that can be going on. You can be playing the game, or the game can be in this start state. So for this update function, if you're in the start state, it really depends exactly what your start state does as well. But actually, maybe in both cases, you might have something like if self.state is start, then do one thing, and otherwise you do a different thing. Maybe even more specifically, if self.state equals otherwise you do some different thing. You do all of the things that you would normally do if you were playing the game. And then probably the same thing happens in the draw function, right? In the draw function, if you're in the start state, maybe you're doing something, probably putting some text on the screen that says, click the mouse to start or something. And if you're in the game state, then you're doing all of the things that you need to do when you're playing your game. Yep.
I have a syntax question.
Mm-hmm.
Under the class, make one indent and then you go start playing.
Yeah.
And you give it
Yeah, okay, so there's a couple of things going on. So one of them is a sort of easy one. So in Python you can do assignments to tuples. So that's something you won't see in too many other languages. But I can put basically a tuple of variables on the left-hand side of an equals operator and the same length tuple of values on the right-hand side, and it just does the one-to-one thing. So this code here, x comma y equals 3 comma 4, that is the same thing as saying x equals 3, y equals 4. Okay. So up here, that's saying here's two variables, one called start, the other called playing. Assign the value 0 to start and assign the value 1 to playing. Yep.
You wrote start. Do you need to define start elsewhere?
Okay. So this is the second part of this thing. So one is just the syntax of this assignment, which is nothing special to do with objects or self or anything. This is just the tuple assignment in Python. The other thing that's happening is inside this class, my game is where I put that line of code. And what that does is, well, it introduces these variables called start and playing and sets them to 0 and 1. But how do you get these variables, or how do instances of these things get these variables? So these are variables now that anytime I create an instance of my game, in this example, there's only one instance of my game, but for other classes there can be many instances of them. Those instances can access those variables just as if they belong to them. The only difference is there's only one copy of those things. So when I say it's not as obvious in this thing because there's only one instance, but in my missile command game, there were a couple of these types of class variables that were in that game. And actually what they were used for, and what they typically use for in pygame, for example, is if the game has an image associated, if the object has an image associated with it and it's the same image for all objects, you typically put it in one of these variables. Then that means you load that image once when the game first starts up, and then every time you create a new object, you're not creating a new image because they're all drawing the same image anyway. So that's where you see it. But that's fine. Just the only thing to look out for is that means if one of these objects changes that image, then it changes for all of them. So it's a little bit like a global variable, but its scope is limited to just the objects in that class. Okay. So now every my game object that I create you say self.start, and unless it gets changed, that'll mean 0. That's synonymous with 0 now. Okay, so then back to this question about a start screen. So for example, so I'm going to do the lazy thing. So now you see this thing is scrolling away saying we're in the start state because that's where we started it. So every time it draws, now it's just printing we're in the start state. But you could imagine that it has instructions on the screen to how to start the game. And the only thing left then is to introduce some way of going from the start state to actually playing the game. And again, that's, it depends how you want to do it. But since we just handled the mouse click anyway, we might do something like if self.state equals self.start, then we'll say self.state, self.playing. Okay, we're in the start state. You can imagine we loaded a font, we printed a thing that says click the mouse to start, and then the user comes along, clicks the mouse, and now we're forever in the playing state. We're playing the game. And you know, maybe then they play for a while, they lose all their lives, and it's game over. Then the state, you can change the state again to the game over state, or back to the start state, or whatever you want. Does that make sense? So usually, you know, if you can think of sort of totally different things that are happening in your application, like the user is changing, you know, choosing their difficulty level, or is you're waiting for them to be ready to start, versus they're playing the game, versus the game is over, then usually that means you introduce a state variable for your game, and you handle things differently depending on what that state variable is equal to. Okay. Other questions? Okay. So then maybe what I would like to do is, I sort of had an idea, so I kind of like classic arcade and classic console games. And when I say classic, I mean like from the 1980s classic things. So there was an old console and arcade game called Asteroids. And in that game, what you were was a spaceship, started out in the center of the screen, and asteroids, little boulders, would come rolling along and try and crush you. And you had a couple of things you could do. You could fire bullets to smash them up before they hit you. You could rotate your ship, so change its direction, and it always shot. The bullets always come right out the front of the ship. And that was by, well, it depends on exactly what console or what interface you were using. But, you know, joystick left would rotate counterclockwise, joystick right would rotate clockwise. And you could thrust, which, this is where things got interesting. So a little bit of fire comes out the rear end of your ship, and you imagine that you get pushed a little bit in that direction. Now, and that's where things got interesting, because once you were traveling in a direction, you keep traveling in that direction. And so it's not that you let go of the thruster and the ship stops. You press the thruster and it starts moving, and then inertia is there, and apparently this thing is in outer space in a vacuum, so it's perfect. It just travels forever. And, you know, with more thrust, you can build up more speed. So, you know, if you don't turn and you keep thrusting, well, then you just keep going faster and faster in that same direction. And then the tricky bit is when you tried to, when you wanted to slow down, you have to turn your ship around and thrust in the opposite direction. And usually you don't get it turned around exactly, and then things get really hairy. And I always thought that game was, it was whatever, funnish game to play, but the physics bothered me a little bit. I always thought that they were cheating, because you have this, they got it right that yes, every time you thrust, it adds some inertia in some direction, but this idea of the thing just rotating on itself perfectly like that didn't make any sense. Why doesn't that also follow the same rules of physics? I mean, really what should happen is you say, I want to rotate clockwise, and so you put some thruster on, for you guys on here, and that pushes you a little bit, you know, that moves your back end a little bit, and you sort of rotate a little, what looks to you guys like clockwise, to me counterclockwise. And if you push that thruster again, you'll rotate faster, and if you keep pushing it faster and faster. And the way you should stop is not by letting go of the thruster, but by, you know, applying the thruster in the opposite direction. So I'd like to make sort of a version of this game where the physics is consistent. So both turning and accelerating basically use the same kind of rules. One of them, though, is about sort of rotational inertia, and the other one is, just the usual physical inertia, your position in space. So let's do that. But if anyone wants to stop me and ask me another question in the meantime, we can do that. Yep.
I was having a lot of difficulty trying to get the store to go with the timer. How do you set up the clock in a game and have an event go every so often?
Well, there's a couple ways to do it. So let's. So already we are doing that in basically even in the skeleton code. We call this pygame set timer, and what does pygame set timer do? It just sends us an event every so often. In particular, in this case, it's once every 333 milliseconds. 33 milliseconds. So it sends us a timer that way. So couple of things. We can either just use that. So that's like a clock now that's ticking, right? It's ticking 30 times per second. So we could count things off using that as a clock. Or if we want, we can set another timer that sends a completely different kind of event and then handle that event. So which would you like to try?
Using this one seems fairly straightforward, especially if it's already in the skeleton code that we've been using.
Okay, so in fact, I think this is the skeleton code. One of the things that the skeleton code does, for absolutely no reason, is it introduces this variable called frame number that starts out at 0, and every time it updates, it increases this frame number by 1. All right, so what might you want to do is, I don't know, let's say you want something that happens every 1 second or so. Well, so then I might say something like, if so take that frame number, it's an integer, and if it's a multiple of 30, that means that the number of ticks that have elapsed is a multiple of 30, and there's 30 ticks per second, so that means that you're on one of those seconds. Okay? So, and if it's a multiple of 30, that means that the frame number mod 30 is equal to 0. So let's see if that. Tick, tick, tick. So there you're getting an event, something that's happening every 1 second. This is us catching it in the update loop, but every time this refresh event happens, which is 30 times a second, there's also a draw. So we have an opportunity to do something in the draw function as well if we want. But if it's a score increase, then probably it makes sense to put it in the update loop. You might say something like self.score plus equals 10. If it's a survival game and you get 10 points every second you live, then that's the kind of thing you might do. And if you're going to do that, then don't forget to introduce self.score. scores 10, 20, 30, 40, and so on. And if you want to combine that with the previous thing, maybe your score shouldn't be increasing when you haven't even started the game yet. Maybe that only makes sense if you're in the playing state of the game. So you might put that only in that block of code there, in the stuff that executes when you're playing the game. So nothing exciting for a bit. And then the score starts increasing once you start playing. Yeah. Yep. Yeah. And there's a sort of a slight glitch in what I just did, because I'm counting this off every time that the frame number is a multiple of 30, I'm increasing your score. But that means that the first time your score increases somehow depends on exactly when you click start the game. So, because when you start the game, the frame numbers count from the beginning, and then you click start, and maybe, the next time your multiple of 30 could be anywhere between 0 and 30. But you can figure out how to fix that. The most obvious thing would be, mouse button was clicked, self.state equals self.playing, self.frame num. Let's reset that back to 0. So as soon as I press click, the frame number gets set to 0, and then exactly 1 second later, actually, immediately you get a score, because 0 mod 30 is 0. But so you get the idea, I think. So that's a sort of natural way to do it, is use that thing to keep track of time. Alternatively, you can do exactly the same type of thing that I did here. So let's try something like that. Which is to set a timer that sends me a talk event. And it's supposed to be, the units here are milliseconds. So let's say you want that to happen every 2 seconds. So that would be 2,000 milliseconds. And that means that I'll see a new kind of event. I think you can have more than one timer running at a time. Talk. So there you're seeing these other timer events, these custom timer events happening. So it's up to you how you want to manage that.
And what's the significance of the +1 or +2 after the user event?
Okay. Yeah. So pygame has all this list of events, like mouse button down and refresh. Oh, not refresh. Mouse button down. There was mouse button up. There was key press, or key down, key up, all of those things. So those are just integers. They're like 1, 2, 3, 4, 5. And sometimes you want to make your own event types, like the ones that the timer sends you. So what you need to do then is make sure that, not to have conflicts, you should, your event in numbers should be different from all the ones that are built into pygame. And so for that, it provides this thing called pygame user event, which is just a place for you to start counting your own events, right? So there is nothing that pygame generates that's in the range pygame user event or pygame user event plus 1 or pygame user event plus 2 plus 3. So I'm free to use those and define them however I want. I called one of them refresh because it happens 30 times a second, and the other one talk because it sounds like a tick. But you name it. And I don't want these two things to have the same integer, to be the same value, because then I won't be able to tell the difference between refresh events and talk events. Okay. Other questions? All right, good. So like I said, I'm happy to answer questions at any time. Game scale, and what did I want to call this thing? Asteroids. So if I'm going to make an asteroids game, and really I'm more interested in the physics of the ship itself than in anything else, so let's start with that part, the ship. Should probably give it an initial position, and maybe we'll let the default be that it just sits there at that position. So I have this thing in my game that is a spaceship, and the typical thing is it's traveling in some direction at some speed. And that's what vectors were made for, right? Vectors tell you, if you like, direction and speed, or they just tell you how many x coordinates and y coordinates. It's the same thing. So let's have a vector that keeps track of our travel. Initially, that'll be 0. All right, and I also want a similar thing to happen with the rotation of this ship. So I want that if the thing is rotating, clockwise at some speed, then or at some rate, then it should just continue to do so forever unless something else, something stops it. So in the same way that it will keep moving in a certain direction at each click of the clock, it'll also keep rotating in a certain direction. Now, movement like this is on this two-dimensional board that's, there's sort of 2 dimensions, x and y. But rotation is just sort of a one-dimensional thing, right? It's like how much does the angle change each time the clock ticks. So I might say self.rotation. We'll keep a variable for that, but it's just one number. And it'll say maybe, every time the clock ticks, your angle maybe changes by 1 degree. Now, so that's the speed at which you're rotating, but at any particular, well, we should, so that's how these two things measure how things are changing. And I guess then we can ask, well, what is it that they're changing? Your travel vector, well, that's changing your position, right? So you're at a current position x and y, and then the thing updates, and now you move at x plus this travel vector, and y plus this y component of the travel vector. So we have a position, and that's initially given to us. And this rotation vector, well, you're always facing in some direction. It's not necessarily the direction you're traveling. Spaceships can do that, right? They just float. They're not like cars. They can float, sideways or whatever. So you also have an angle that you're facing. So this rotation will affect the angle at every clock tick, and this travel will affect your position at every clock tick. So we'll work out our... So every time you want to update yourself 30 times a second, you would do something like self.angle equals self.angle plus self.rotation, and self.position like so. Okay. And usually, at least the way I like to design them, these game objects draw themselves on a screen, so we'll need to figure that out. So I'd like my spaceship to look like a spaceship. I think I have an image here called ship2.jpg. Yeah, that looks like a spaceship, kind of. So ship image is okay, so now I've got an image for this ship. All right. Now, if I want to draw this ship, so you saw the image, looks like that. Now, when it's time to draw it on the screen, what should I do with this image? I guess we can just start with the most obvious thing and then see what we need to fix. So let's just do something that we use all the time. That's where we say I want to draw an image at a particular position onto some screen, and I want the image to be centered. So we've seen a recipe for that. You get the image as rectangle. You then move the rectangle so that it is shifted to the left a bit by half the width of the image and shifted up a bit by half the height of the image. So that's a rectangle dot width over 2, rectangle dot height over 2. Position at 0, position at 1. Okay. So if I just move this rectangle to position at 0 and position at 1, that would put the top left part of the image there. I want to put the center of the image there, so I subtract off half the height and half the width. So if I want to draw myself on the screen, then I will draw centered. I want the ship image. I want to put it at my current position, and I want to do that on that screen. Okay, so there's a super rudimentary spaceship class. It doesn't do too much yet, but let's just test it out. So that means I need to create a new spaceship. So self.ship is a spaceship, and we'll put it right in the center of the screen. Okay, and now when I update all my game objects, I should update my ship. And when I draw all my game objects, I should draw my ship. See if that works. It will be miraculous if I can write that much code and it actually works. Of course, it never does. So spaceship is supposed to take 2 arguments, but 3 were given. And this comes back to a question that somebody asked already this class. Why was I using double parentheses? And that's because I'm only supposed to give 1 argument to spaceship, which is its position, and it's supposed to be a vector of 2 things. Okay, good. So there's my spaceship. I see one little issue here is that the background color on the spaceship doesn't match the background color of this thing. Probably should have got a transparent spaceship image, but for now I can cheat that and just change the background color to match it. It kind of takes away the illusion of this blackness of space, but whatever. Okay, so there it is. And it's updating and it's drawing at every frame 30 times a second. Can't really tell much because we set all of the parameters initially to not, there was no rotation, there was no translation. So let's see if we change that a little bit. So when I create my ship, what if I have it rotate by 1 degree? Initially. Let's see if that works. No. So that's not doing anything. Self.shift.rotation equals 1. Oh. Actually, maybe it is doing something. Let's set both of these things simultaneously. What was that called? Travel. Okay, so now the ship is taking off in the vector direction 1, 2 at that speed, and now it's gone forever. Okay. So I don't like that it's gone forever. Anybody familiar with asteroids? What happens when you run off the edge of the board? Yeah. So asteroids is played actually not on a rectangle, but on a torus, which is the shape that you get when you take a rectangle and you glue its 2 vertical edges together. At the same time, you take its top and bottom sides and you glue those things together. You get a shape called a torus, which you guys know as a donut. So asteroids is actually played on the surface of a donut. But we need to implement that because we haven't done that. And sort of the natural place is, well, you might think when the ship updates itself, it should pop out on the other side. But again, the board that you're playing on, that's somehow a property of the whole game. It's the whole game that knows the width and height of the screen. The ship doesn't know that. So we should have the game deal with it. And so when we update the ship, well then we might do something like update its position or readjust its position modulo self.width. There it goes. So that was off the bottom and out the top, and now it will go off the right and in through the left. All right. So that's being played on a donut now, which you may not have realized. Okay, but I said here that when I created this thing, I set the rotation to 1, but I don't see any rotation happening. What's wrong? Yep. Yes. When I drew this thing, I just take the original image here and draw it at the current position. Well, the original image is a ship that's pointing that way, or for you guys that way if you look up there. It's pointing off to the right. I need to, if I want to show it, if I want to draw it in such a way that you can see what angle it's pointing, I need to actually rotate that image before I draw it. So that's with pygame transform rotate. I'll take the ship image and I will rotate it by self.angle. And the thing that I'm going to draw is not the original ship image, but this newly rotated image. If the image was reasonable, then that rotation will look like it's happening around the center. But here's where that's where it's important to get a symmetric image, or one that's whose dimensions are right. So let's see if that's working. Okay. So now it's rotating 1 degree per frame, which means after 360 frames, or a couple of seconds, a little more than a second or so, we'll see a full rotation. Okay. Good. So there's our ship, and it seems to be doing what it's supposed to do. It has this sort of rotational inertia that it's holding on to, and that keeps changing the angle, and it has a positional inertia, that's this travel vector that keeps changing the position of it. So now we want to now we'd like to introduce some way to control this thing. And this is where you actually get that maybe you want to do input slightly differently. And, well, we're almost out of time today. But this is where you use this model of input that I don't care when the user presses the key down, and I don't care sort of when they let it go. More what I care about is how long they're holding it. So if they turn on the thrusters, then as long as they're holding them on, I want something to happen. And it's not really the transitions that matter, but it's the duration. And so to deal with that, that's when we go back to these pygame functions, which look like, what did I say? Pygame something like get keys. Okay, so pygame has this pygame.key.getPressed, which will give me a list of all of the keys that are being held down right now. So if the user is holding down 10 keys, it'll give me a list of all of them. And so let's just see when we do that. And I'll just try and do this super fast. So during an update, if pygame.key.getPressed if the key is at key space. Space bar will be my thrust bar. So if that's true, then I'll say self.ship.thrust. And what happens when you thrust the ship? Well, we need to define what that means. So that means we need to push the ship in some direction. And what is the direction? Well, that depends what direction the ship is facing in. So a little bit of math, and we'll say alpha is equal to and see if that works. K space. Where are you? Okay, I'm going to try thrusting now. Oh. Looks like the math is a bit off. But something is clearly happening, right? But the math's a little off somewhere. Yeah. Okay, so exercise for you guys. What was this whole business about this alpha here? So first of all, why did I create this thing called alpha? And what's its relation to angle? Or what should have its relation to angle been? It looks like it's not quite right.
The circumference divided by 360, so like a unit vector for the circumference?
Yeah. So what's happening here is there's a difference in units between what we want and what pygame uses. So pygame is using units in angles of 360 degrees. That's the unit pygame uses. For us to use, for example, the math library, we want radians, so angles as between 0 and 2 pi. So we're doing this conversion from the pygame angles to those other things. And just as an interesting side, a very expensive rocket once exploded precisely for this reason, where precisely I mean two pieces of software in the rocket were using different units of measure, and they were not converting between them correctly. So you can see I've made the same mistake here. We'll figure that out at the beginning of next class.
I tried to approach the assignment and it says I was only able to handle like one file at the same time.
Yes.
Around 9 o'clock. But when I looked at it right now, allows
Yeah,
me
so-
to add more. So I was just wondering.
Yeah, so I upped the limit yesterday because people were having problems. In the future, what I recommend is you submit a zip file,
Okay.
just with everything in it, because then you can submit as much as you want. The system won't let me allow you to submit more than 20 for any particular assignment.
So what should I do? Because I only submitted question 1 on the thing, but
Yeah.
just the 5 file, but like there's no image or anything, and there's no question 2 or 3 was handed to it. So what can I do?
I mean, I don't know. So you tried it, what, 9 o'clock last night, and then
Yeah, it's
you
like
gave up?
Yeah, it's around like 9 o'clock. I have that submission.
I don't know. Send me an email and I'll try and get a TA to mark it for you.
Okay, thank you.
Ouch. What's up?
I wanted to ask a couple of things.
Mm-hmm.
First is that
Yep.
the